Welcome back. Today we are going to start with Mod 11, and that deals with pressure. It also deals with different phases of matter, and then specifically gases, where we talk about gas pressure. So I'm kind of going to hop around a little bit, and I'm going to tackle today doing what we call gas calculations. We will be taking different aspects of the gas, such as its temperature, its volume, its pressure, and making calculations about that gas. So, to start off, our handy dandy reference tables, right? They're very important, so make sure you get those out. The formulas that we are going to be using, you can find on page 3. Okay, they're going to be all the ones that have a P in them. P is for pressure. And over here on this side tells you what all the letters, the variables stand for. And every one that we do today will contain a P because every one of these have to do with gas pressure. Okay? So just so you can see, I'll show you the ones we're going to be using up close. So if you see this one right here, it says P1 V1 over T1 equals P2 V2 over T2. And I'll talk more in detail about what all of that means. We'll jump down here to this one that says PV equals nRT. And then we'll go back up to this one that's like PT, well, that means P total, pressure, total pressure, equals, and then the partial pressure 1 plus 2 plus 3 and so on. Okay, so those are the three we're going to be talking about. Also, in these formulas, or at least in one of these formulas, you're going to need to plug in something called an R, which is a gas constant. You're going to see an R in one of the formulas. I want to let you know where you're going to find that because it will not be given to you in the problem. Okay? Instead, on the very front cover of your reference table, right up here at the tip top, you're going to see where it says gas constant R. And there's 3 different values that we're going to plug in that are possibles for R. What I want you to notice when you look at this is that when you look at the units for R, they're pretty much the same except for what's up here in the top. This first one right here has atmospheres, ATM. This one right here has millimeters of mercury, and this one right here has kilopascals. So when we go to choose from this list for R, we're going to need to make sure we pick the R that matches the pressure we're using. All of these are pressure units, so we're going to want to make sure that we choose an R that will match the pressure that we're using in the problem. Okay, so you're going to choose from these 3 R's depending on what pressure you have. Okay? All right, so why don't we start with the very first formula, which is PV equals nRT. So I want to talk specifically about each one of these letters, what they represent, and when you see a number followed by its unit, you'll be able to identify it as either being pressure or volume or whatever just by the unit that follows the number. So let's first talk about the P. The P is for pressure. In every single formula we use, when you see a P, that P is for pressure. So how do you know which one of the numbers that you're going to be dealing with is the number for pressure? Well, it will be followed by one of these 4 pressure units. It will either be ATM for atmospheres, kPa for kilopascals, torrs, or mmHg, which is millimeters of mercury. Any number that is followed by any of these units will be your pressure number, and it would go in this spot, okay? Now, next door to that, we have V, which is volume. Volume is going to be anything in the liters family. So I just put liters here. So if something in your problem says 5 liters, 10 liters, whatever that number is, followed by the liters, is going to go in that V spot right there where the volume goes, okay? Now let's come to the other side of the equation, and we have N. Everybody loves some moles, so what do you know? They're here. The good news is, in this module, you don't have to convert between grams or moles. If I'm just going to give it to you in moles. So when you see that number that says, 5 moles, 2 moles, whatever, N is the letter in the equation that represents moles. So that number must go in that spot, moles. That brings us to our R. This is that gas constant I showed you a while ago on the reference table. If you remember, there were a choice of 3 values there, and I'll just show you to that again, just to make sure you know it's right there on the front cover. You have 3 values to choose from. So here they are. The gas constant, you need to match it to your pressure. So if your pressure is in atmospheres, so if that P that you plugged in was in atmospheres, then you're going to choose the R that is 0.0821 to go in that R spot. If by chance the pressure you're dealing with in your problem is in kilopascals, then when you come to choose your R, you have to choose the one that corresponds to kilopascals, which is the 8.314. And lastly, if you're dealing with a pressure that is torrs or millimeters of mercury, they use the same for R. So that is going to be 62.4. Again, R will never be provided to you. You're expected to look at it or find it on your reference table. That brings us to temperature. Now, I know that most of the time when you talk about temperature, you say that it's in Fahrenheit, right? Degrees Fahrenheit or degrees Celsius in this class, Celsius. But for the purposes of gas calculations, which is everything that we are doing in this module, your temperature has to be in Kelvin. If you do the math with anything other than Kelvin, you will get it wrong. Okay? So that means that if I tell you that the gas is 25 degrees Celsius, you cannot plug in 25 in this spot. Instead, you must convert it to Kelvin and plug that Kelvin number in to do the math. So how do you change the degrees Celsius to Kelvin? You simply take that number and add 273 to it, and that will change it into Kelvin. So if something is 10 degrees Celsius, to change it into Kelvin, you would add 273, so it would be 283 Kelvin. If something is negative 10 degrees Celsius, then it would be 263 Kelvin. So that's how we put everything in place. Now, this is basic Algebra 1. What's going to happen on every single one of these problems is you will be asked to solve for any one of these, except R, of course. R is always provided for you on your reference table, so you're never having to figure out R. But for any of the other variables, whether it be pressure, volume, moles, or temperature in Kelvin, you might be asked to solve for those. You will have one unknown, one X that you don't know, and you will know every other thing. So you'll be able to plug a number into every single spot except for the one you're solving for. And then you're just going to do Algebra 1 and solve for what that missing variable is. Just that simple. Okay? So again, we will do some sample problems in a little bit, but it might be good to screenshot this right now and have that just as a reference as you work problems. Okay? Now, we'll move on to our second formula. Now, the one thing I do want to say about this one before I put it up is anytime your problem is dealing with moles, whether it gives you moles, whether it asks you to find moles, if moles is anywhere in the whole hood, you must use this formula. This is the mole formula. So what if it doesn't have moles in it? What if there's no mention of moles whatsoever? Then we can't use the formula that has an N in it because there would be no moles. We need a different formula for no moles. So this is called the combined gas law. And if you notice, it's only P's, V's, and T's only. No R's, and most importantly, no moles. So when your problem does not refer to moles in any way, then this is the one you have to use. Notice that P is still pressure, V is still volume, temperature is still in Kelvin, T is still your temperature in Kelvin, and again, that's how you change it. You have what we call ones and twos. This is before and this is after. This is the initial and this is the final. So basically we have a gas that we put through a change. It started out having a pressure of whatever, and we did something to that gas. What is its new pressure? So these are the beginning values. These are the ending values. This is the initials. These are the finals. Okay? P, V over T, all initials, equals the final pressure, volume over temperature. And again, hate to beat it with a stick, but your temperature has to be in Kelvin or, all right? Okay. This is the no moles formula. Still deals with pressure, still deals with volume, still deals with temperature, but no moles. Okay. Now, last but not least, let's take a hop, skip, and a jump over to this formula. This is the last formula we're going to be learning in Module 11. And notice that there's only P's. There's no volume, there's no temperature, only some P's. So this is the formula that we use when we are mixing gases together, multiple gases together, combining them into one container. And we want to find out what the total pressure for that mixture would be. You need to understand that gas pressure is additive, okay? Which means as you combine in more gases, you just keep adding in their pressure. And the sum of all those what we call partial pressures, which are the individual gas pressures, basically you just sum them up and that gives you the total pressure. It's just that simple. This is called Dalton's Law of Partial Pressure. Okay? Now, there is a quiz, your first little quiz thing up. It is multiple attempt. I give you very strict instructions about how to give me your answer. Again, it's multiple attempt. You can take it as many times as you need to. Please keep up though with your score so you'll know where you are and if you've taken it yet. So it's going to be up to you to kind of keep a count of, are you done with this quiz or not? Okay. Now, what I would like to do now is I have about, 5 or 6 problems that I would like to work with you, okay? So if you don't mind, I am just going to carry myself over here to my second location, which is my little board over here. So give me just a minute to come over here. Yes, okay, perfect. Okay. Okay, so, okay, here we are. Okay, so what I want us to practice doing is it's one thing to know what the formulas are. Like, okay, P's or pressure, blah, 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 I got all that. It's another thing to be able to read problems and decide which of those 3 formulas you're supposed to use and how to use them. So, I have gotten some sample problems here. And by the way, if you print out your notes or look at your notes that I've attached in this module, these are the same problems that are there for the most part. Some of them might be different and they may not necessarily be in the right order, but oh well. Okay, so this says, what pressure? I don't know. That must mean I need to find out, right? What pressure in kilopascals would 0.5 moles. There's a special formula for moles, and because I see the word moles, it immediately tells me I have to use the one for moles, okay? Moles of gas at 50 degrees Celsius occupy at 10 liters. What pressure in kilopascals would 0.5 moles of gas at 50 degrees Celsius occupy at 10 liters? So, because I see that word moles, and I know when I look here at my little list on the formula, and I know that moles is an N, I know my formula has to have an n in it, okay? Now, what's also helpful, I think, is to go through, and when you see a number like this, is to go and check on your reference tables, like right here, and just look at your list, and you would see that, okay, where do I put moles? Well, if you look right there, it says the number of moles is N. So I know that I've got to have an N in my formula. I also noticed that that is temperature, okay? So I know I've got to have a T in my formula as well. And I also remember that liters is volume. So I've got to have a V in my formula. So the first thing I did was I went and identified all my numbers with what variable represents that unit. So moles is N, degrees Celsius is temperature, and we know we've got to change that to Kelvin, but we'll get to it. L is liters, which is volume. Now, once I identify all my numbers, then I say, well, what am I solving for? I need a letter for that too. And it says, what pressure? So I know I also have to have a P as well. And I say to myself, of those formulas that deal with pressure that Ms. Tart just went over, which one of those has a P, an N, a T, and a V? Well, guess what? Only one. This one. P, V, N. Remember, R is something that you're going to get off your reference table, and T. So R is never going to be in the problem. But this is the only one that's got the P that I'm solving for, the volume in liters, the moles, and the temperature. So this is the one that I am going to be using. So we're going to be using PV equals NRT. So here we go. Do I know my pressure? Absolutely not. That is what I'm solving for. So I'm going to leave it a P. Going to just keep it its letter. Okay? That's my X. That's my unknown. Do I know my volume? Well, right there, 10 is my volume. So I'm going to come right here and put my 10. Other side. N is next. Do I know my N, which is my moles? Oh, yes, I do. It is 0.5. Okay? Now, R. Remember, R is never going to be here. Instead, it is here. So I say to myself, this pressure, my R has to match my pressure. Well, I don't know what my pressure is, but the problem tells me it won't sit in kilopascals. So what I'm going to do is I'm either going to go to my reference table or I'll go back to this and I'll say, if it's kilopascals, my R has to be 8.314. 8.314. Finally, that takes us to my temperature. I'm told it's 50 degrees Celsius. You better not be plugging in 50 degrees Celsius. No. Instead, what you need to do is pick up your little calculator and you need to say 50 plus 273 to get that in Kelvin, and it is 323. All right. So, does everybody agree? I've plugged in all of the numbers in the right spot, and I have the unknown that the problem is asking for. What pressure in kilopascals? There it is, right? So, all we're going to do now is solve for P. So what I suggest you do is you multiply all of these together, so we're just dealing with one number right here. So I'm going to say 323 times 8.314 times 0.5. And I'm going to get 1342,711 equals P, and then this is 10 point that. You see where I'm going now? So then this simply becomes something very much like this. See if this rings a bell, okay? Who remembers something like 2n equals 4, okay? Do you agree we have a variable and a number on this side, just like right there, and then we have the number on this side. So what we're going to do is we're just going to divide it out, right? So it will say what that equals. So I'm going to do the same thing here. I'm going to divide out. Always, the cardinal rule of Algebra 1 is to always isolate the variable. That means that you never, ever, ever bring a number to the variable. You always take it away from the variable. So that means there's my variable. In no way can I take this number and bring it over here. Instead, I have to divide out the 10 and take it here so that the variable ends up by itself. So then all I've got to do is say P equals, and 1342.77 divided by 10 equals 134. 134. Sorry about that. Bring it down a little bit. 134. And we were looking pressure, and the problem told me it wanted in kilopascals, so that's 134 kilopascals. Okay? So that is an example using that formula there. So let's move forward. All right, to our next problem. Okay, we will take one that looks like this. Okay, it says, the temperature of 10 liters of a gas changes from 25 Kelvin to 100 Kelvin. What is the new volume? Pressure remains constant. Okay, guess what I didn't hear in that problem? I did not hear moles. Nowhere. That means that this formula right here that has moles in it cannot be used because the word moles is not in this problem. So no to this. So that means I'm still dealing with volume and temperature. So, but this one, because no moles. So when you don't see any moles, but you see those same things like the volume and the temperature and the pressure and those words, but no moles, we're going to use this one instead. And just to be on the safe side, just so you know, 10 liters, again, we're going to identify that as our volume, right? 25, a K is for Kelvin, so that is temperature. Looks like to me I got another one of those Kelvin temperatures. Temperature, got two T's. So I've identified every single number. So then I ask myself, what letter am I solving for? And it says, what is the new volume? So I'm solving for a volume, okay? Notice that it says pressure remains constant. That means that pressure ain't a player. That means we're not going to put the P's in this formula. Anytime something says it's held constant, that means just take it out. Take all the P's out of the problem if it says pressure's held constant. If it says volume's held constant, you take all of these out. You get to remove anything that's held constant. All right. So, do you agree I have two V's? I've got the one they gave me plus the one I'm solving for, and I've got two T's. So right there, two V's, two T's. What I'm going to ignore, however, so when I go to write my formula, and I've got P1 V1 over T1 equals P2 V2 over T2, when that says that pressure is held constant, it simply just means I'm going to remove it from both sides. It is not a part of that problem, which kind of simplifies my formula, okay? That means all I got to do is insert those numbers where they go, okay? Now, I know I'm solving for the new volume. So which one of these B's is the new volume that I want? That one. The new is the second one. It's the final one, okay? It's the after one. So this is going to stay a V. That is my unknown I'm solving for. That means where all these other letters have to turn into numbers. So what is my initial or first volume? It says it's 10, so I'm going to put 10 here. What is my first temperature? Well, it says it changes from 25 to 100. So 25 is my first and 100 is my second. It went from 25 to 100. Notice that there's a K there, which means that it's already in Kelvin. I do not have to make any conversion. I can use that temperature because it is in Kelvin. I'm simply going to change my first temperature to 25, and I'm going to change my second one to 100, and again, they're already in Kelvin. I have everything plugged in except for the one variable I'm solving for. Now, this is where we're going to do math, kind of like what I call the butterfly method. All right? So if we butterfly this thing, do you agree? I'm going to have a butterfly wing here, and I'm going to have a butterfly wing here, right? So what we're going to do, and I wrote this, you're going to probably want to write this down just so you always do it this way. What we're going to do is we're going to do the wing without the variable, always want to put it in parentheses, divided by, in parentheses, the wing with the variable. Close your parentheses. So that means I'm first going to go with the wing without the variable. Do you agree that this wing right here has a 10 and a 100 in it, no unknown variable? So I'm going to say 10 times 100, and it's going to give me 1,000. Okay? So that's the wing there, divided by the wing with the variable, 25 times V. So that's just going to be 25, equals 25 V. Now, this right here is a way that you don't, because if you did it on paper, what you could do, and I'll go back to this, this is your shortcut way without having to write it down, but I'm going to show you what we're doing here is we're doing the wing without the variable equals to the wing with the variable. And then just like Algebra 1 says, we're going to divide out, right? And then V, which is my volume in liters, is going to equal 40 liters. But I want to show you this without having to do and write down. Okay, so this is where it's going to come back to this. If you pick it, whenever you have your wings drawn like this, all you have to do is to enter it in the calculator this way. The wing without the variable. That was my 10 times 100. You just leave it in your calculator, okay? Divided by, and then remember we're going to do our wing with the variable. Everything has to be in its own set of parentheses. So parentheses 25. And you get 40, okay? So again, enter the wing without the variable, 10 times 100, divided by parentheses wing with the variable, okay? Wing without divided by wing with. All right, so let's move on to our next example. And I'm kind of mixing these up. That way we're having to kind of think through rather than do them all the same, okay? That way we'll kind of go back and forth. All right. So, oopsie, slide that over a little bit. Here we go. How many moles that calls for a special formula, of gas are in 2.5 liters at 20 degrees Celsius and 600 millimeters of mercury of pressure? Okay, so, sounds like I need to be looking at my mole formula, right? So I know that I'm using this formula because I just read the word moles, and that immediately points to this formula, okay? But just to be sure, let's go through and identify everything. 2.5 L is your volume. 20 degrees Celsius is your temperature. Millimeters of mercury, if you remember from your list I told you a while ago, anything that ends with millimeters of mercury is going to be your pressure. And then we always say, what am I solving for? And it wants to know how many moles, and moles is N. So again, if you did miss the point that moles immediately points you to this formula, when you look at the fact that you've got to have a formula that has N, V, T, and P in it, then there's none other, my friend, than PV equals nRT. All right? This time, the unknown I'm solving for is the N, so that's going to stay an N, okay? As far as plugging in my other letters, my other numbers in the letters, 2.5 liters is my volume, so that's going to go there. And notice that I don't put in my units. I just like to look at numbers. The only letter I want to see in my math problem is the variable I'm solving for. So I only put in the numbers, okay? Now, my pressure is 600. So I got my pressure times my volume right here. And then my moles, I don't know. I'm going to leave it in N. That will be my only letter that I'm going to be looking at. My R, remember, I'm going to go back to my reference page, or I'm going to look right here, and it says if I'm dealing with millimeters of mercury, which I am, I'm going to use 62.4 for my R, and then my temperature, of course, has to be in Kelvin, okay? So that means I have to say 20 plus 273, which will take me to 293. Okay, so basically what I would do is I would multiply these two numbers together, so I just end up with one number with that N. And then I would multiply these together, and I'll do this for you real quick. So if I do 62.4 times 293, I get 18,283 N, and I'm just going to keep my variable. I'm just switching the side just because I like the way it looks over there. And then that is equal to 600 times 2.5, and I get 1,500 here. Again, we're just going to do follow the old algebra rule, where I leave the N here and I take that number over. I divide that out and I get my answer, which is, just for the sake of doing it, 18,283.2. I get 0.08. And that is moles. So that will be 0.08 moles. Okay. I'm going to do one more. Well, actually, maybe two more problems. Okay. All right. So let me erase this real quick. And I am going to do okay. So let me find my other problem I'm going to do. Here it is. We will do this one. All right. 6.2 liters, well, that sounds like volume to me, of gas is at 278 kilopascals. That's one of those pressure units. And 35 degrees Celsius. Sounds like temperature to me. If the volume and temperature increases to 25.8 liters, what do you know? That's another volume. And the temperature goes to 100 degrees Celsius, what do you know? That's another temperature. What will the new pressure be? So do you agree? We need another P because we're solving for that. What you didn't hear me say was the word moles. which means that we have to use the pressure, volume, temperature formula that does not include moles, which is this one right here. So we are going to be using P1V1 over T1 equals P2V2 over T2, okay? If you look, I've got V's, I've got P's, and I've got T's. So absolutely nothing is removed. We're going to use all three variables twice, okay? 2 P's, 2 V's, and 2 T's. So we just got to plug them in. But let's first figure out which one of these is the one I'm solving for. So I know not to plug a number in that spot and to leave it its letter. It wants to know what will be the new pressure. New. New means that one right there, the second one. The second one is the new one. This is the old one. This is the new one. So we are going to keep this. This is what we are solving for. That means I got to plug a number into every other spot. So what is my first pressure? We'll identify that as my first pressure. So it's 278. Okay? My first volume is the 6.2 liters. And again, I only put numbers in. The only letter I want to look at is the one I'm solving for. First temperature says it was first at 35 degrees Celsius. Remember, no can do, don't be plugging in any Celsius, okay? 35 plus 273 gives me 308 is going in this spot right here, okay? Now let's go to the other side. It says that the volume and temperature increased to, so that means my other volume is 25.8, and my second temperature is 100 degrees Celsius. So plus 273 is 373 Kelvin. All right. So what we're going to do is we're going to follow those same rules and we're going to butterfly it, right? So we're going to have a butterfly wing here, and we're going to have a butterfly wing here. This one has the variable in it. This one does not. So rather than deal with these big numbers, watch what I do. Okay? Here we go. Parentheses. I'm going to be dealing with the wing without the variable, which is this one right here. So inside those parentheses, I'm going to say 278 times 6.2 times 373 equals, and I will get this big old honking number, like 642,000. I don't want to write all that down. So as long as I do the wing here and I multiply every single thing in that non-variable wing, and I've got that. Now I'm going to say divided by, and I'm going to divide it by the numbers in the variable wing. Okay, so this has the variable in it. So these have to be in parentheses. So divided by parentheses 308 times 25.8. Close my parentheses so it looks just like that. Okay, equals, and I get 80.9. 80.9. And again, I didn't have to write down all of these big long numbers, but in order for you to do it that way, you have to say wing without the variable divided by parentheses wing with the variable, okay? And we got, what was it, 80.9. And that was pressure we were solving for. And it's because our pressure was in kilopascals, that the first pressure was in kilopascals, that means that the second one was too. Whatever you put in is the same unit you get out. All right, now, enough of these two formulas. Before I leave you on this video, I want to just throw up one more problem. A lot. Okay. that deal with that third formula that I call Dalton's law of partial pressure. So that's when you combine or mix gases together. Remember, pressure's additive. So it says 3 gases are combined. The partial pressure of gas A is 2 atmospheres. The partial pressure of gas B is 3 atmospheres. And the partial pressure of gas C is 1 atmosphere. We're going to take A, B, and C, mix them all together into one, and I want to know what the total pressure is. So anytime I talk about combining or mixing gases, that means that you're going to be looking at this formula here. The total pressure is equal to the partial pressure of each individual gas. And it could go on. It could only be 2 gases, but you got to at least have 2 to have a mixture, right? So I'm going to show 3 here. This gas, our first one, has a pressure of 2, plus this second gas has a pressure of 3 atmospheres, and the last one has a pressure of 1 atmosphere. The total pressure is simply what you get when you add them up. So 6 atmospheres is the total. It's just that simple, okay? So then what if I ask it a different way? What if I said, and again, the total pressure for a mixture, those keywords, mixtures, combining gases, those are going to let you know that you have to use Dalton's law of partial pressure, which says this. Now, this one only deals with 2 gases, I think. So it says if the total pressure is 100, so I'm giving you the total, what the sum of those 2 would be is 100. I say, what is the pressure of the first gas, or gas A, if gas B has a pressure of 85? So basically, what is that missing other gas? Duh. What do you have to put here to get to 100? 15. And that is kilopascals. Okay? Now, following this video, there is a Google quiz, classroom quiz, again, multiple attempts. I have it in sections. The very first section deals only with this formula right here. So you'll only be using this formula in the first section of the quiz. The second section, you're going to be using this formula, the no moles formula. Okay, again, if it says something's held constant, you simply take it out of both sides. If everything's present, then you work it with everything. Remember, this is where we do our wings, okay? All right, and last but not least, the last section deals with mixing gases or combining gases using Dalton's law of partial pressure. It's multiple attempts. Try your best. Give it your best shot to get to close to 100 as you possibly can. If you just can't get there, remember, contact me. I'm free all week. I'm pretty much stuck here, and I can help you get through it. All right? Until next time.